In this video, we're going to discuss example 16.3 in the textbook. It states, adjust the three equally weighted distance observations taken in feet. Now, equally weighted, that means the weighted value is equal to 1 between points A, B, and C. First off, let the unknown distance AB, so from this point here to this point here, and the distance from B to C be X and Y. So it's just saying this is X and this is Y. These two unknowns are related through the observations as follows. Okay, X plus Y equals a total length of 393.65. Let X be a value of 190.4 and let Y be a value of 203.16. Now, values for X and Y could be obtained from any two of these equations, so the remaining equations are redundant. However, notice that the values obtained, let me scroll this over, obtained for X and Y will differ depending on the two equations that are solved. It is therefore apparent that the observations contain errors. So we're saying if you add these two together, it's not going to give you the total of this value here. So we know that there's some type of error in there. So what they say is, okay, write the equations, but include the residual errors. So we had these original equations here, and now we have these equations here. And all you did is add residual errors. The next step states that to obtain the least square solution, observations equations J are rearranged to obtain expressions for the residuals. So we're trying to solve for R. Remember, we had the residuals squared is the sum from the starting observation to the last observation. How many observations do we have? We have 3. So the first observation is X plus Y minus, all we did was take this value here and bring it over and subtract it. Okay? X minus 190.4 is, we just rewrote this equation and brought it X minus 194. And we're just letting everything equal to its residuals. So this is V1, this equation would be V1, this equation would be V2, and this equation is V3. Now, the function K is in the equations, it's what it's basically saying. Okay, this is J, this is K. It says function K is minimized, enforcing the conditions of the least squares by taking the partial derivatives. All right, when you take a partial derivative in calculus, basically when it's got something to the power of 2, you take that power and you bring it down to the front. So it's 2 times, and it's the same equation as the residual. And then in this one, it's 2 times. So we're taking a derivative with respect to the x's. Notice this last one has absolutely 0 in it because there's no x value there. That's why it gets dropped off. Now when you take the partial derivative of the residual squared over the partial of y, then you're basically saying, okay, I've got a y value in here. So you're going to take the squared down, and you're going to come up with x plus y minus 393.65 plus 2. Notice there's no x value in here now. This one has, both of these show up in these equations because there's an x here, and we're talking about the derivative of x with respect to x. And this one shows up because it's got a derivative with respect to y. We're not going to be doing calculus in this class. We're not going to be doing derivatives, but this is the explanation of how it works. Now the next step says reducing the formal equations and solving for x equals 190. So if I'm looking at this, I'm saying, all right, this value here is, let me put the x back into it. So I'm going to say x plus 203.19 minus 293 equals a negative 0.03. Okay? We're going to say that the residual of V2 is equal to 190.43 minus 190 equals positive 0.03. And residual 3 equals 203 minus 203.16 gives me a residual of positive 3. All right. I'm going to hold on to this. I'm going to move on to the next lecture, but I'm going to start it in another video. All right. That's it for this video now.